Hello and welcome. In this series we are going to build a stock recommendation system using Python and MySQL. In this particular video we are setting up MySQL and create schemas where we are storing tables containing stock prices of index components. Therefore, we are first of all installing MySQL on your system and then populate the database with stock price data as shown in this chart here. As I'm usually working with US data, I thought it would be interesting to take a look at other markets, but of course the concepts I'm showing here are applicable to US stocks, Asian stocks, European stocks, or wherever you're based. Also, you should know that the concepts are scalable, so I'm using 3 indices here, but you can take way more than that. So let's take a look at what markets we are taking a look at. We are taking an Indian index, Namaste. We are taking a Brazilian index, Hola. And we are taking a Russian index, Здравствуйте. Some prerequisites: you should have an idea what MySQL is, you should know the difference between a schema and a table, and optional, my video on building a simple stock recommender, and my videos on the intersection of Python, Pandas and SQL. A lot of you followed my request from last week, thank you very much for that. I would really appreciate if you continue helping me to improve this statistic. Okay, so first of all, let us install MySQL. Of course, if you are already using MySQL, just skip this part. I will only cover the installation process for macOS. I remember the installation process for Windows slightly more painful. I will see that I link resources on how to set it up on other operating systems as well. By the way, I'm using the macOS version Big Sur. So we need 2 things here: the MySQL community server and the MySQL Workbench, which is kind of a user interface to interact with MySQL. So we are clicking here, and then I'm just downloading the most recent version here. If you have, for example, an older operating system, you have to browse through the archive here and just see if it is compatible here. You see Mojave is compatible here, and so on, right? But I'm just using the most recent version here. Same for MySQL Workbench. So if you are using Big Sur 11.1 or newer, you can use this one here. So I'm using this one. But if you have an older system, you have to browse through the archives here. Okay. I already downloaded both, so I just want to save you some time. And yeah, let's start with installing MySQL on your system. So this is the MySQL community server download here. So we are just starting that. And install this. So of course I already read that beforehand. I'm just presenting that to you. Okay, here, I mean, it's your choice. I'm picking strong password encryption. In this field, you have to set a password for the root user, and I'm just picking a very simple one, which is of course not recommended, but only that you have an idea what I'm doing later when connecting MySQL to Python. So I'm just picking 1, 2, 3, 4, 5, 6, 7, 8 here, okay? And then we are finishing that. And now you see installation was successful. Okay, and now if we are going on the system preferences, you are noticing that you have this dolphin here, right, with MySQL. And you see that the MySQL server is running. You can stop it, but why should you now, right? But here you can stop and start MySQL server. And I've checked Start MySQL when your computer starts up, which I would basically recommend if you're using it frequently. Okay, that's it for MySQL Server. And now we want to install the Workbench. Now we've installed it and can open it here. Yes. And now I'm not going much into MySQL details here. Maybe I'm covering that in another video. But what you need for this video is that you're accessing this local instance here. By double clicking it, provide the password which we have just set up. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And now you are here in this user interface. And what's important here is, so here you can write SQL queries, select star from wheresoever. And what's important is the schemas, where until now is only the sys schema. And what we are going to do now is to create one schema for each of the mentioned indices. The stocks contained in those indices are the tables, and those tables contain the price data. So in the end we have 3 schemas here: Nifty, RTSI and Bovespa, containing all stocks and their particular prices. And from now on we are using Python to achieve exactly that. Okay, so first of all we need to install some necessary libraries. We need sqlalchemy. I've already worked with that in my Python and SQLite videos. Be kindly invited to check them out. And we need PyMySQL. Okay, once you've installed them, we need to import them. So import sqlalchemy and also PyMySQL. What's important is to execute the following line every time you are working with this approach of connecting to MySQL. So we're using install as MySQL DB. And now we just want to create 3 schemas. One Nifty 50 schema, one RTSI schema, and one Bovespa schema. And for that, I'm just creating a simple list here and just create Nifty 50 here, RTSI, and Bovespa. By the way, I have no idea if I'm pronouncing that right, so correct me if I'm pronouncing it wrong here. Okay, now we have a list of the indices and we want to create schemas which have those names, right? And for that I'm creating a function, which I'm just schema creator, which is taking an index, and therefore I'm creating an engine with sqlalchemy, and here I'm providing the connection string. And this is looking like that. We are using MySQL, and here we are providing our user. And as you might remember, our user was root. We're using a colon and provide our password. And as you remember, I picked 1, 2, 3, 4, 5, 6, 7, 8, right? And also we have to define the host, which is just the local host. And as you saw, it was this port here. So this is our connection string. Now we want to take this defined engine and use the create schema function. So we can use engine execute, which is just executing particular SQL queries. We can just use sqlalchemy schema and then create schema and take the index as an argument for that. So this is the schema name. Okay. So again, we are creating an engine, connect to our MySQL database with this connection string here, and then we're just creating a schema with the name we are providing to this function. So let's execute that. And now I'm just using this function and provide all of those indices, right? And I can use a simple loop for that. So I'm just picking for index in indices and just call my function schema creator, and provide the index, which is just the element or every element in this list here, right? So let's execute that. And let's switch to MySQL. Now let's refresh this. Now you see we have 3 new schemas here, right? Bovespa, Nifty, and RTSI, which are until now empty, right? But nevertheless, we have created them and we want to populate them in the next step. So yeah, first of all, we need to get the ticker symbols for all the contained stocks in the Nifty, in the Bovespa, and in the RTS. Therefore, I have to import pandas. We also need that for other functionalities in the next steps, so it's important to import pandas. And now I'm just using the read HTML function from pandas. I've covered that in a lot of other videos on my channel. What I'm doing is just scraping data from a Wikipedia table. And pandas has a handy function for that, which is the read HTML function. I'm just copy pasting this syntax here. So I've manually searched for the HTML tables here. So if you have a better way, of course, be kind invited to drop me a comment. I was using a particular Python library to achieve that, but it just has not sufficient data. So I'm still going the hard way here, right? So what I'm doing here is I'm creating 3 variables and just read out tables from Wikipedia. So I'm showing you how this is looking like. So for example, the Nifty is looking like that. So we only need those symbols here to request online stock price data. So we can reassign Nifty to nifty.symbol to list and store this column here into a list, which is containing the ticker symbols for the Nifty. Right, so now we have this list here. Okay. Same for Bovespa. So let's take a look at that. Here the column is looking like that. So we are taking the ticker column, Bovespa equals to Bovespa ticker to list. And last but not least, we have RTSI or RTS and have the ticker symbol here. So we are reassigning RTS, use the ticker symbol column and store that to a list. Right, so now we have the RTS symbols here. Now, what's really important is to do some amendments, because those tickers, so let's take a look at Nifty again. Here you see that we have .ns for the National Stock Exchange, right? And we don't have that for Bovespa. And the problem with that is that we are not getting sufficient data if we are using those ticker symbols. We have to add .sa for that in the case of Brazil. And also we have to add ME in the case of RTS. So how can I know that? Because I've looked up one of those ticker symbols and didn't find sufficient data for the Russian and Brazilian stocks, and the reason behind that is that we have to add this .sa. So let's reassign Bovespa and use a list comprehension to achieve that. So we are using I plus and then .sa for I in Bovespa. And now we have the correct ticker symbols here. Okay, and same logic for RTS. So here we're using I plus .me for I in RTS. Right, and now we have the correct ticker symbols. Yeah, as said, not the best way, but it is how it is. This is the workaround, and only with that it is working, at least from what I know until now. Okay, so we have defined all our ticker symbols which we need, right, to get the price data. To request online stock price data, we just have to import yfinance. So of course you have to install it beforehand in case you didn't already. And I'm quickly showing you how this is working. So you're just downloading, then provide a certain ticker symbol. Let's just take the very first one of the Nifty and let's just start most recently. And you're getting a data frame like this, right? And I want to get a data frame for all those lists here. So for Nifty, Bovespa and RTS. So, and I want to get that for, let's say, the last 12 months, right? So let's just start in the beginning of 2020 for all those. And I want to store this data into the database, the MySQL database. So this is what I'm doing in the next step. To do so, I'm creating a variable here, which I'm calling mapper. And this is just a dictionary, which is mapping the schema name to the symbols which should be stored in this particular schema. So I'm starting with Nifty 50 and provide the Nifty list to that. Use Bovespa and provide the Bovespa symbol list to that. And also the RTSI is mapped to the RTS list here. Okay. I think to better understand the next step, I'm showing you how I'm using this dictionary. So I could use for symbol in mapper and provide Nifty 50, for example. I'm just printing out the symbol. You see, I'm just getting the symbols for the Nifty. So this is how it's working. And this syntax I'm using in my next step. So now I want to get all the price data and store them in the MySQL database. This is what I'm doing. For that, I'm using a nested loop, and the outer loop is using the following: for index in indices, and those indices are just Nifty, Bovespa and RTSI, right? And for every of those, I want to define an engine so that sqlalchemy knows, okay, in which schema I'm moving now. So I'm defining engine here, use sqlalchemy again, create engine, and I'm just copy pasting the syntax from above here. So I'm just pasting that here, but I'm also adding plus the index here. So this is just telling sqlalchemy, okay, I'm in the schema. So in the first iteration, I'm in the schema Nifty 50. Okay. So this is the outer loop. So I'm getting an engine for every single schema. And now inside the schema, I want to do the following. I want to use for symbol in mapper and then take the index as I just showed you. So this is the same as before. And here I want to download. So I'm just storing the download to a variable here. I want to use yf download and provide the symbol. And I'm starting, as I just said, I'm starting in the beginning of 2020, right? What I have to do also is to reset the index. This is due to the fact that I don't want to have the date column as the index. I want to have it as a column. So I said it wrong. The date is the index of this data frame, and I want to reset the index so that the date is a column. And now I just want to get this data frame into the SQL database. And I've covered that in another video, so I will link that in the video description. I can use the toSQL function from Pandas, provide the symbol here as the table name, and the engine, which is in the very first iteration Nifty, so that I'm storing that in the Nifty schema. In the second one we have, the second one was RTSI, and so on, right? Okay, now if I'm executing that, I'm getting the data into our MySQL database. So let's do that. And now we see we are getting a lot of online requests here, and this will take some time, of course. But essentially what we are doing here, again, to summarize that, for every symbol in all those lists, Nifty, Bovespa and RTS, we are creating a data frame which is containing stock price data for every day since 2020, and we are storing this data into our MySQL database. So while this is populating the database, let's take a look, because some of the data is already imported. So let's refresh that and take a look at Nifty now. And now you see we have tables. And you see now we have, for example, the Asian paint. And this is just the price data for Asian paint since the beginning of 2020. And we have this nice table here. Pretty awesome, right? And yeah, let's take a look at the script again. So it is executed, so we have all the data. Let's do a quick sanity check if we got all. So therefore I'm just doing the following. I can just take a look at, for example, the length of Nifty. 50, yeah, of course 50, good. Bovespa we have 73, and RTS we have 50, 73 and 50. So I want to get the number of tables for Bovespa, for example. I can use select count star as total number of tables from information schema tables, and then the table name, where table schema is. Let's check for Bovespa, execute this, and now we see we have 73. Perfect, was working perfectly. Wanted to type in Russia, sorry. RTSI, we have 50, perfect, and for the Nifty 50 we have 50. Okay, so yeah, that's it for this video. In the next video we are going to apply some technical analysis, maybe some more stuff to this data, and build our recommendation system. So I hope you liked this video. If you have any questions, feel free to drop me a comment. Be kindly invited to leave me feedback if this content is interesting for you. And yeah, thank you very much for watching, and I'm looking forward to seeing the upcoming videos. Bye bye.